Okay, so let me discuss this. Okay, let me discuss it. Okay, all right. So how to calculate this resultant force? Okay, we have 3 kilogram object, and then there's a 7 Newton force pushing downward. So if you want to calculate resultant force, of course, usually we will have more than one force, right or not? So where is the other force? We only see 7 Newton. Where is the second force here? The second force is the weight of this object. Okay, is the weight. So we need to calculate the weight. So what is the weight? The weight is mass times the gravitational acceleration. So that is why this question gives us the gravitational acceleration. Alright, so in order to calculate the resultant force, okay, we take and usually if the force is downward, then we take it that the direction is negative. Okay, we take it that the direction is negative. But because both of these force is going in the same direction, both also going downward, so it is not necessary to put the negative lah. Because if everything is in the same direction, it is not necessary to contrast to show there is a different direction. You understand what I'm saying? Okay, if all of the direction is in the same direction, okay, all also going down, then it is not necessary to put negative to show that it is going down, because everything is going in the same direction. You got put negative, you don't put negative, everything is the same. So there's no, it doesn't see that got any different. Okay, doesn't seem to have any different. Alright, so resultant force. So we want to calculate resultant force, so we just take the two force and add together. So the first one is a 7 Newton lah. Second one plus this one mass times gravitational acceleration. So 3 times 9.81. Okay, so what is it that you get? You will get 36.43 Newton. So this 36.43 Newton will be the resultant force of 7 Newton and the weight combined together. Alright. Okay, so next, this one, same thing also. The weight is the second force. So the weight can be calculated by take the mass times the gravitational acceleration. Okay, now you see the two force is in the opposite direction. So you need to put one of them as negative, and usually we put going down as negative lah, going up as positive. Okay, so 7 Newton is positive, plus this one weight going down is negative. Okay, so the mass is 3, and the gravitational acceleration is downward. Okay, downward accelerate downward. So the direction of the acceleration is negative 9.81. This is how we get the negative for the weight. Okay, for the direction of the weight be negative. The negative is at the direction of the acceleration. Okay, because mass have no direction. Mass is not a vector quantity. Acceleration is a vector quantity. So gravitational acceleration have direction, and the direction is going downward. Okay, so we get negative 22.43 Newton. So 22.43 Newton, negative 22.43 Newton is the resultant force for this, for the resultant force for the weight and the 7 Newton. Okay, so this is how we calculate the resultant force for parallel forces. That means the two forces are parallel to each other. The direction of the two forces are parallel to each other. So you see, Okay, 3 Newton, 7 Newton parallel. This 7 Newton, 3 Newton is parallel, although in different direction, but they are still parallel. Okay, both also horizontal. This one both also vertical. This one although different direction, but both also vertical. So that means they are parallel to each other. Okay? Any problem? Okay, so just now is we learn how to determine the resultant force for parallel forces. Okay, very simple. Just sum the forces together. Okay, now how about non-parallel forces? Non-parallel forces, that means the two forces are in different direction. Okay, it's not parallel. Okay, the first for non-parallel forces. Okay, the resultant force can be determined by drawing scale diagram. Okay, this is called the parallelogram method. Okay, draw scale diagram or the parallelogram method. Okay, so first we look at these two perpendicular forces. The first situation is if the two forces are perpendicular to each other. So perpendicular to each other means that they are 90 degree lah. Okay, 90 degree perpendicular to each other. Okay, so how to find out the resultant force for perpendicular forces? Okay, so draw a scale diagram to determine the magnitude and direction of resultant force of a 5 Newton and a 9 Newton force acting perpendicularly on an object. So the scale is 1 centimeter to 1 Newton. Okay, so you need compass, protractor, ruler, and pencil. Actually, you don't need compass. You don't need compass. Okay, you just need protractor, ruler, and pencil is enough. Okay, I recommend you use pencil. If you use a pen, then if you draw wrongly, then difficult to change. Okay, if pencil, then you can erase right. Okay, now before we start drawing, I want to explain a little bit about this parallelogram method. Okay, so just now we say that resultant force is the single force that have the same effect as two or more forces act together. That means a force that have the same effect as two or more force. So that means that one single force can represent two or more force. Okay. So we look at this situation. We have a 5 Newton pull upwards. We have 9 Newton pull to the right. What do you think? Where do you think this object will go? Logically, if you pull in this direction, this object will go in this direction, right? Not somewhere in between here. Okay, the object will move somewhere in between here. Okay, so how to find out this object when move this in this direction? What will be the acceleration? Because we have force act on this object, so that means this object will definitely have acceleration. And what will be the exact direction of this object? How do we know? How do we determine the direction? We use angle. Okay, we use angle. So we can measure this angle or this angle. Okay, this angle or this angle to show the direction of this object. Okay, this object move in which direction? How much is the acceleration? Why is it that we want to know the acceleration and the direction? Because the acceleration and the direction is the effect of force. Okay, both of these are effect of force. Force act on an object, the object will accelerate in a certain direction. Okay, so the acceleration in a certain direction, that is the effect of force. So we have 5 Newton force, we have 9 Newton force act on this object, and this object will accelerate in this direction. Okay, so if we want to find resultant force, basically what is it that we need to do is we need to find the force, one single force that can make this object accelerate in this direction with the same direction as these two, with this same effect as these two forces. Okay, so we can use this parallelogram method. Okay, parallelogram method. So what is this parallelogram method? Okay, so parallelogram method is where we draw a parallelogram to represent the forces that act on a certain object. Okay, so the scale here is 1 centimeter to 1 Newton. That means 1 centimeter represent 1 Newton. Okay, 1 centimeter represent 1 Newton. Okay, so 1 centimeter represent 1 Newton. Okay, so first we draw this 9 Newton, or we draw a rough one first. Okay, we draw a rough working first. So this 9 Newton here, because it's 9 Newton, so we need to draw 9 centimeter. This one here, we use protractor, we measure 90 degree. Okay, we use protractor, we measure 90 degree, and then we measure 5 centimeter because this force is 5 Newton, so 5 centimeter. After that, we draw this 9 centimeter over here. Okay, over here we measure 90 degree also, and we draw 9 centimeter, and then at the end we connect here. So here we'll also have 5 centimeter. Here is 90 degree, 90 degree, all also 90 degree. Okay? So these lines, all of these lines represent the force. Okay? Represent the force. Okay. So how is it that we can find out the resultant force? We connect here, this point, and this point. Okay, we connect this point and this point, connect together. After we connect together, we take the ruler and we measure. Okay, we take ruler and then we measure from this point to this point, how long is the line. Okay, how long is the line. So, because 1 centimeter represents 1 Newton, so whatever the length, how many centimeter, okay, how many centimeter will mean how many Newton lah. Okay, how many centimeter will equal to how many Newton is the resultant force. And then the direction, you use protractor to measure this angle lah. Measure this angle with protractor, and then you can get the direction of the resultant force. Okay? Okay, so I show you, okay, I show you. So I draw on the screen. I draw on the screen, I put my ruler on the screen to measure lah. But I hope that you do the same thing on a piece of paper. If you did not print it out, if you print it out, then you can draw directly in the space in the note lah. Okay, in the next page there's a big space. There's a big space where you can draw. Okay, so this is the next page. Okay, this is the next page where you can draw. Okay, I prepare a very big space for you lah. Okay, so you can draw here. Okay, so what we do is we draw, we measure, use ruler and measure. Okay, 9 centimeter. Okay, I draw 9 centimeter. I draw a long line first. Okay, I draw a long line first. Okay, and then I measure. Okay, and then I measure 9 centimeter. Okay, so if start from here, then 9 centimeter will be here. Okay, this is from my screen now. Okay, this is from my screen. I hope that you are doing the same thing. You also draw on a piece of paper. Okay, and then after that you take protractor. Okay, here to here is 9 centimeter. But you don't write 9 centimeter lah. You label this as 9 Newton. Okay, you label this as 9 Newton. Must draw the arrow to show the direction of the 9 Newton force. Okay, so we get a protractor. Okay, measure 90 degree by using your protractor. Okay, from this point. Okay. All right. Okay, should have 90 degree, Okay, and then measure 5 centimeter here. Okay, I measure 5 centimeter. Okay, so this is 5 Newton. This 5 centimeter represent 5 Newton. Alright. Okay, now I can, so now I measure, this is 90 degree, Okay, so I either measure 90 degree here and you draw 9 centimeter, or you can measure here 90 degree and you draw 5 centimeter here also can. Okay, so let's say that I draw here lah. Okay, from here I draw, I measure 90 degree and then I draw and I measure 5 centimeter here also. Okay, so here also 5 centimeter. So this one also represent 5 Newton. And then we draw a line to connect here to here. Okay, between these 2 points. So this point until this point. Okay, so this one is going to be 9 centimeter also lah. Okay, so if your drawing is accurate, then you can also get 9 centimeter. Okay, this one also 9 Newton. Okay, this line also represent 9 Newton. Okay, after this, we draw a line that join this corner with this corner. Okay, like this. So this line, this diagonal line will represent the resultant force. Okay, this will represent the resultant force, Fr. So how to know how many Newton is the resultant force? All we do is we just take a ruler and measure lah. Okay, so I measure here, I get 10.3. Okay, I get 10.3 centimeter. Okay, so I get 10.3 centimeter. So that means what? So the resultant force will be equal to Fr will be equal to 10.3 centimeter. So that means 10.3 Newton lah. Why 10.3 Newton? Because 1 centimeter represent 1 Newton. That is the scale that is given by this question. Okay, 1 Newton represent 1 centimeter. 1 centimeter represent 1 Newton. So 10.3 centimeter. So it is 10.3 Newton. Okay. So do one last measurement to make sure it's correct. Okay. So next is we want to find out the direction. Okay, we want to find out the direction. So we use protractor to measure this angle. Okay, we want to see what is this angle. Okay, so by using protractor, I do not have protractor right now. Okay, so I measure using my protractor. I put my protractor on the screen and I measure. Okay, so I get I can get 29. Okay, 29 degree. Okay, I can get 29 degree. Okay, so I get 29 degrees. So the resultant force will be 10.3 Newton. Okay, 10.3 Newton. To the direction of 29 degree from 9 Newton force. That means 29 degree from measure from the 9 Newton force. Okay, that is what it means by 29 degree from 9 Newton force. Okay, so this is the resultant force. So this resultant force, this 10.3 Newton to the direction of 29 degree from 9 Newton force is the force that will have the same effect as 5 Newton and 9 Newton acting on the object perpendicularly. Okay, perpendicularly to each other. So that means this object, the object here, it will move in this direction. It will have acceleration in the direction of 29 degree from the 9 Newton force. Okay, get the idea. And the acceleration can be calculated if we know the mass of the object lah. So we just take the 10.3 Newton, okay, divide by the mass, and then we can get the acceleration of the object. Okay, get the idea. Okay, this is parallelogram method. So the reason why we call it the parallelogram method is because you see this diagram is a parallelogram, right or not? Okay, this 9 Newton and 9 Newton parallel. This 5 Newton and 5 Newton here is parallel. So this is a parallelogram. Okay, parallelogram. Alright. So why is it that you look at this diagram, this parallelogram, it can represent the direction of the force. This direction of force will be the same if the force is acting in another way. For example, from push become pull, from pull become push. Okay, so for this question, the 5 Newton and 9 Newton is pulling on the object. Okay, 5 Newton and 9 Newton is pulling. Okay, is pulling on the object. That means like this. Okay, let me copy this. Okay. If you see if the object is here, let's say that the object is here, pull with 5 Newton, pull with 9 Newton, then logically this object will move in this direction. Right now. Okay, now let's say that the object is here. Okay, let's say that the object is here. If the object is here, that means it's being pulled by 9 Newton and being pushed by 5 Newton. That means 5 Newton push this object up. 9 Newton pull this object to the right. So logically, this object will also go in this direction, right now. Okay, this object will also move in this direction. So that means this resultant force with this angle, with this direction, also can represent the resultant force if this object is being pushed by 5 Newton and pulled by 9 Newton in this direction. You see or not? Okay? And same thing also, if the object is here, is being pushed by 9 Newton to the right and being pushed by 5 Newton upwards. Okay, upwards. Then this object, logically, this object will also move in this direction. Okay, the object will also move in this direction, and same thing also. If the object is here, let's say, is being pushed by 9 Newton, being pulled by 5 Newton, okay, then this object will also go in this direction. So you see, this resultant force, it will be the same for all of these four situations. Don't care whether it is being pulled or being pushed by the 5 Newton force, 9 Newton force. Okay, don't care whether it's being pushed or pulled, the effect will be the same. Okay, the resultant force will be the same. See, all in the same direction. Okay, all going in the same direction. Okay, and with the same magnitude also lah. Okay, get the idea. Okay, so of course the reason is the effect of the force will be the same. Don't care whether it is being pushed or being pulled. So let's say an object being pulled with 1 Newton, an object, same object, let's say 1 kilogram, being pulled with 1 Newton, then the acceleration will be 1 meter per second per second. If this 1 kilogram object is being pushed with 1 Newton, the acceleration will also be the same, 1 meter per second per second. So don't care whether it's push or pull, the effect will be the same. So you see this, the logic in this parallelogram or not? Okay, the direction of the forces. Okay, that means don't care. This parallelogram can represent the effect or can represent the resultant force. Don't care whether the force is push or pull. Okay, in all 4 situations also can. Okay, if you have any question, make sure to ask. Okay, from the above scale diagram, a right angle triangle can be obtained. So that means you look at here, we can get a right angle triangle. Where do we get the right angle triangle? Okay, for example, let me copy this. Okay, so you see, we can get right angle triangle from here, 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 or here, here, and here. Okay, you see you can get 2 right angle triangle right now. Okay, either here or here. Okay, here or here. So we can get 2 right angle triangles. Okay, so let's say we take this one. Okay, so let's say that we take this right angle triangle. We will take this one, the green color one. So that means from this right angle triangle, okay, this is 9 Newton, this is 5 Newton, this is the resultant force is 10.3 Newton. This one, the angle is 29 degree. Okay, you see. Alright, so from the parallelogram or from the scale diagram, we can get a right angle triangle. So if we can get right angle triangle, that means what? That means the resultant force of 2 forces acting perpendicularly to each other can be calculated using Pythagoras theorem. Okay, we can calculate by using Pythagoras theorem. Okay, because it's a right angle triangle, so we can calculate the length of this line. Okay, the length of this diagonal line we can calculate by using Pythagoras theorem. So the direction of the resultant force can be calculated using trigonometry. Okay, this angle we can get from trigonometry. This length we can get from Pythagoras theorem. Okay, right now. If that is the case, that means since we can calculate, that means it is not necessary to draw the scale diagram. That means if you want to find the resultant force, you can also calculate by using Pythagoras theorem and trigonometry. So that means like this. So now we see how we calculate. Okay, so we want to calculate the resultant force. Okay, so 9 square plus 5 square, whole thing square root, then you get, okay, you see 10.2956. Okay, so that means if we round off, we will get 10.3. Okay, we will get 10.3 Newton. You see, so it is exactly the same from our parallelogram. Okay, from our scale diagram. Okay, 10.3 Newton. And then the angle. Okay, we can get the angle by using the trigonometry. So we can use, we know 5 Newton, we know 9 Newton. That means we know the opposite, we know the adjacent. So we can use trigonometry. Tangent theta equals to tangent opposite over adjacent. So 5 over 9. So the angle will be, okay, again, exactly 29. Okay, 29.05 lah. Okay, 29.05. But if we round off, also can get 29. Or okay, we make it 29.1 lah. Okay, to be more accurate. Okay, 29.1. Okay, 29.1 degrees. So that means the resultant force equals to 10.3 Newton to the direction of 29.1 degree from 9 Newton force. Okay? Get the idea? Okay, however, even if, however, it is very important to understand the parallelogram method. Okay, to understand the parallelogram method, because question can ask you to draw. Okay, question can come out, ask you to draw. Please don't think that, oh, I know how to calculate, so no need to learn how to draw. You must learn how to draw before you learn how to calculate. Because the way that we calculate, the reason why we can calculate by using Pythagoras theorem and trigonometry is based on the parallelogram method. Okay, Anna? Okay, anybody have any questions? Okay, just now we already learned how to find the resultant force if the two forces are perpendicular by drawing parallelogram. Okay, now how about if the forces are non-perpendicular forces? Okay, non-perpendicular, that means not 90 degree. Okay, even if not 90 degrees, same thing also. We can draw scale diagram to determine the magnitude and direction of resultant force. So this time is the 5 Newton and the 9 Newton force is acting at an angle of 60 degrees from each other on an object. Scale is the same, 1 centimeter to 1 Newton. So you need compass, protractor, ruler and pencil. Again, compass is not necessary lah. Okay, most important, you need protractor, ruler and pencil. Okay, so again, draw parallelogram. Same concept. Okay, let's draw a rough one first. Okay, let's draw a rough one. So like this. So this is 9 centimeter, and then we measure using protractor, measure 60 degree. This one is 60 degree. This is 60 degree. Here also measure 60 degree. Okay, here also 60 degree, and then connect these two. Okay, so this is 5 centimeter, this one also 5 centimeter, and this one will be 9 centimeter. So after we get this, we draw a diagonal line. So the length of this diagonal line will represent the resultant force. And for the direction of resultant force, measure this angle. Okay, measure this angle using your protractor. Alright, so let's start. Okay, so I draw a long line first. Okay, I draw a long line. Okay, a line that is longer than 9 centimeter. Okay, so let's say this is the starting point. I measure 9 centimeter. Okay, here. So this is 9 Newton. Remember, we label it as 9 Newton. We don't label it as 9 centimeter because the length just represent the force. Okay, the length represent the force. Okay, after that we use protractor, measure 60 degree. Okay, measure 60 degree. Okay, I put the protractor on my screen to measure 60 degree. Okay, so this one will be should be longer than 5 cm already lah. Okay, and then I measure 5 centimeter. Okay, I measure 5 centimeter here. Okay, 5 centimeter. So this will be 5 Newton. Okay, this represents 5 Newton. And then again I measure 60 degree on the other side. Okay, I draw the line also. Okay, so this is 60 degree. Okay, this is 60 degree. Okay, this side also 60 degree. And then I measure 5 centimeter. Okay, I measure 5 centimeter and I draw a straight line, connect the connect the 2 points. So this represent 9 Newton, this represent 5 Newton. Okay? Alright, now we draw a diagonal line. Why we draw diagonal line from here to here? Because logically, this is the direction of the resultant force, right or not? If we have the object here, one force pull this direction, one force pull this direction, so logically, this object will move in this direction, right or not? Okay, the object will move in this direction. So logically, the resultant force will be in this direction. Okay, so this length we can get by measuring using the ruler. We just put the ruler on our scale diagram, and then we can measure. Okay, so we can get 12.3. Okay, so I get 12. Oops. Okay, so the resultant force. Okay, the resultant force is 12.3 Newton. Why 12.3 Newton? Because it is 12.3 centimeter, and 1 centimeter represent 1 Newton. Okay, so 12.3 Newton to the direction of measure this angle. So using protractor, I can get 21. Okay, to the direction of 21 degree from 9 Newton force. So that means this angle is measured from the 9 Newton force. Okay, so that means you see why is it that it's very important to say from where the 21 degree is from where? Because if you just say to the direction of 21 degree, then people don't know where is this direction. Is it here or is it here? You see these two, the angle is different. Obviously this is larger than this angle. Okay, so you have to tell people the 21 degree, where is the 21 degree? Is it here or is it here? And if you say 21 degree from 9 Newton force, that means this angle is also true. Okay, this angle is also 21 degree right now. So 21 degree from 9 Newton force. Okay, this side also true. Okay, so success. Okay, already successful in getting the resultant force of 5 Newton and 9 Newton acting on the object at the angle of 60 degree. Okay, which is 12.3 Newton. That means this 12.3 Newton acting on the object, at the angle of 21 degree from 9 Newton, the force of 12.3 Newton will be able to replace. Okay, or will be able to produce the same effect as the 5 Newton and the 9 Newton force. That means if we know the resultant force, then we don't need this 5 Newton and 9 Newton Okay, we don't need 5 Newton and 9 Newton to get the same result. We can just use 12.3 Newton in this direction, then we can get the same result as 5 and 9 Newton. Okay, get the idea. Okay, we can, if the resultant force is not equal to 0, then we can calculate the acceleration. Okay, effect of resultant force, we can have two situations. First is the resultant force equal to 0. Second is resultant force not equal to 0. If resultant force not equal to 0, it's like this. So we have resultant force not equal to 0, then the object will experience acceleration in a certain direction. This one also, you see, this one, the parallel forces. You see this one, the resultant force is not equal to 0, so that means this object will accelerate. in a certain direction. Resultant force not equal to 0, so the object will accelerate. Okay? This one the object will accelerate, this one the object also will accelerate. Okay? Okay, so this one also lah, resultant force not equal to 0, so there will be acceleration. So here, what is it that we want to concentrate on is what if the resultant force is equal to 0? What will happen? Okay, so when two equal but opposite force act on an object, the resultant force will be 0. Okay, again, when two equal but opposite force act on an object, the resultant force will be 0. Okay, so if the object is stationary, it will remain stationary. So for example, like this, if this 2 kilogram object is originally stationary and you have two 5 Newton forces act on this object, then this 2 kilogram object will continue to be stationary. That means the velocity is not going to change, continue to be 0 meter per second. If the object is moving, it will continue to move in its original constant velocity. That means if this object is already moving, originally is moving at 2 meters per second, suddenly you have 5 Newton act on this 2 kilogram. What happened is this 2 kilogram will continue its original velocity and continue to be constant. The velocity also not going to change. Okay, because the resultant force is 0. If the resultant force is 0, that means it is like there are no force that is acting on the object. Okay, so if there is no force, that means there is no change in the motion. Okay, the motion doesn't change. So for example, here you see, okay, resultant force equal for both situations, the resultant force is 5 Newton plus negative 5 Newton. Okay, 5 Newton plus negative 5 Newton, so you get 0 Newton of resultant force. So if the resultant force is 0, 0 Newton act on 0 Newton act on 2 kilogram. So the 2 kilogram will have 0 acceleration. Okay, the acceleration will be 0 meter per second. Okay, example. Okay, let's say that we have a crate, we have a box here, so that this box we have 100 Newton acting to the left, 100 Newton acting to the right. So the forces acting on the crate are equal and in the opposite direction. So the crate will not move. Okay, the crate did not move. You see or not? So this is the effect, the result. Okay, the effect. Okay, the effect when the resultant force is 0. Okay, this crate is originally not moving. So if you have 100 Newton on to the left, to the right, then the crate is not going to experience, it will not have acceleration. Okay, that means no change in the velocity. Next, when the car is at rest, the weight of the car is balanced by the reaction from the ground acting outward. So the weight and the reaction upward is balanced. Weight equal to the total reaction. Total reaction equal to the weight. Total force going down, total force going up, same. So resultant force is 0. So if resultant force is 0, that means the car will not go up, will not go down. Okay, it will remain on the road. Okay. Aeroplane. The forward thrust balanced by drag. Okay, this is a thrust. The thrust is the force that produced by the engine thrust. And then drag. Drag is like air resistance. Okay, drag is like air resistance. Weight is balanced by lift force. Okay, weight going down, lift force going up. So all force upward balance with downward. Force forward balance with backward. So that means all of the forces are balanced. Okay, if all the forces are balanced, so the plane did not move up or down, continue to move forward in constant velocity. Okay, get the idea. Okay, the velocity of the aeroplane will not change. It will also not go up, not go down. Continue to be at the same altitude. Okay? Alright, so zero resultant force do not change the state of rest or state of motion of an object. The forces are balanced or in equilibrium. Okay, this is a word that we can use to describe this situation when the resultant force is equal to zero. Okay, when the resultant force are equal to zero, there is no change to the motion of the object, then we say that the forces are in equilibrium. All the forces are equal, balanced. Forces in equilibrium. Okay. So when forces are in equilibrium, no change to the motion. No change to the motion means no acceleration lah. Velocity no change, direction no change. Okay? Alright, so when two opposite forces are unbalanced, just now it's balanced, but now if it's unbalanced, resultant force not equal to zero, the object will move with acceleration. So, for example, we have 2 kilogram object, 5 Newton to the right, 2 Newton to the left. What will be the acceleration? Okay, so F equals to MA. The force will be 5 plus negative 2 because 2 Newton to the left. We take the direction to the left as negative direction. Equal, the mass is 2 kilogram, so what will be the acceleration? Okay, we get 1.5 meter per second per second. Okay, and then this one, we have a rocket. The weight of the rocket is 50,000 Newton. The thrust force going up is 55,000 Newton. So what would be the acceleration? Okay, so here the net force. Net force is actually the same like resultant force, but net force basically just means the total force. Okay, the net force basically means the total force is how much. Okay, or the extra force. Okay, the net force, okay, the extra force. Okay, so the net force will be 5,000 Newton, or the resultant force is 5,000 Newton. So F equals to MA. So this force, this F here is 5,000. The mass. Okay, how do we calculate the mass? How do we know the mass is how much? From the weight. Okay, from the weight. So weight equals to mg. So mass equals to weight over gravitational acceleration. Okay, so the mass will be the weight, which is 50,000 over the gravitational acceleration is 9.81 times the acceleration. So the acceleration will be okay, so we will get that the acceleration is 0.981 meter per second. Okay? So this is the acceleration of the rocket.